Hello friends, let us now learn some important points about the Doppler effect. Okay, so first we will learn some important points about the Doppler effect. In the Doppler effect, first this is the blood vessel, and if the blood is flowing, if this is the direction of flow of blood vessel, then the transmitter or receiver will have an angle of around theta. Okay, now this is the transducer. The transducer is placed at an angle of theta. Now, Doppler effect mainly describes the change in frequency or wavelength that occurs when this ultrasound wave will encounter a moving object. Meaning, see, normally a stationary object, if this is the way that the sound produced, if you see the same thing in a moving object, if there is a moving object, then because this object will be moving, there will be change in the frequency of the sound produced. It will change like this. So when the transducer, when you apply a ultrasound beam through the transducer into the and if this ultrasound beam strikes the moving object, this will result in change in frequency and also the velocity. This change in frequency and velocity which encounters when the ultrasound beam reaches a moving object is called as Doppler's shift. From the moving object, the ultrasound beam will be reflected back, and these returning echoes are at a different frequency and different wavelength when compared to the initial frequency and initial wavelength. So, when a moving so through the moving object, if the ultrasound beam will strike the moving object, the ultrasound beam will produce some returning echoes, and the frequency and the wavelength of these returning echoes is different from the frequency or wavelength. So there is a change in frequency or wavelength when the ultrasound beam strikes a moving object, and this change is called as Doppler effect. Now, the if the object is moving away from the source, see, if this is the source, it is moving towards the source. If it is moving towards the source, then frequency will increase. If it is moving away from the source, if this is the source and it is moving away from the source, then the frequency will decrease. Actually, this is the source. This is how the it is moving towards the source. Sorry. Here the frequency will increase. Here it is. This is the way that it is going. This is the way that initial ultrasound waves are going, and it is moving away from the source. So the frequency will decrease. If the object is moving away from the source, frequency will decrease. If the object is moving towards the probe, frequency will increase. Whenever there is angle of the transducer and this moving object or blood vessel is 90 degrees, then the angle of insolation is 0. And when this angle of insolation is 0, cos theta is equal to cos 90 is equal to 0. So there is no Doppler effect. Okay. When the angle is placed at 90 degrees, when the angle is 0 degrees or 180 degrees, then the Doppler effect will be maximum. Generally, we use an insonating angle of less than 60 degrees is preferred to give better or accurate velocities. So, the change in frequency of Doppler effect is equal to 2 times the velocity of interface into frequency of the beam into cos theta by sound wave, velocity of sound in that tissue. So this V is the velocity of interface. This C is the sound in the tissue. So this is called as Doppler effect, and this is the physics behind the Doppler effect. Well, there are some important types of Doppler effect and where do we use them? We will see them in detail. Okay. One, we have something called as continuous wave Doppler. So this continuous wave Doppler is mainly used in handheld devices. In handheld devices, especially in cardiotopograms for fetal heart wave. To know the fetal heart wave, we have fetal Doppler like cardiotopogram in gynecology department. That is actually a continuous wave Doppler. Here, the Doppler effect is emitted by by an audible sound, and here two important things. In the transducer, there is a separate two crystals are present. One will transmit the sound, and the other will receive the sound at the same time. So the one which transmits the sound and the one which receives the sound together. So as a result, there are two crystals here. And because the transmission of sound is continuous and the receiving of sound is also continuous, we call it as continuous wave Doppler. The main advantage is this two crystal continuous wave Doppler is cheap, it is easy to use, it has good high sensitivity to flow. But the disadvantage is that it insonates all vessels in the beam of the path. So it does not, we cannot pinpoint the vessel, but it will start insonating all the vessels. We cannot measure the velocity and we cannot even measure the location or depth of where we are focusing. All of them is not possible in this continuous wave Doppler. But the main application of continuous wave Doppler is to find the heartbeat of the baby, of the infant, not infant, fetus, sorry, fetal heartbeat. In order to find the fetal heart rate, and also we can use this continuous wave Doppler. And we can also use to measure high velocities from transvalvular gradients, like aortic stenosis or tricuspid stenosis. In them also we can use this continuous wave Doppler. The next type of Doppler, which is also important, is pulsed wave Doppler. In pulsed wave Doppler, there is only one crystal, and the same crystal will transmit the ultrasound images, and when they are echoes are formed, these echoes are returning echoes are also received by the same crystal. The transducer sends the ultrasound waves, and then this there is pulsed transmission. It will send the ultrasound waves and it will wait and listens for the reflected echoes. So number of ultrasound pulses. So there is pulse repetition frequency. What is this pulse repetition frequency? Pulse repetition frequency, the number of ultrasound pulses emitted by the transducer. Number of ultrasound pulses emitted by transducer per unit time is called as pulsed wave Doppler. So brief pulses of ultrasound energy are emitted. So if you have to see high superficial vessels, for high superficial vessels, we can use high PRF pulse repetition frequency, whereas for deeper vessels, it is better to use low pulse repetition frequency. So, if with every emitted pulse, there is a pulse which will returning signal is seen. So, as a result, we can determine the depth or location of the reflector can be determined with the help of this pulsed wave Doppler. Whenever this pulsed wave Doppler is combined with B mode imaging, then we can call it as duplex scanning. If this pulsed wave Doppler with B mode and along with that if you add a spectral or color Doppler together, then we call it as triple triplex scanning. We can call it as triplex scanning. Then the next important type of Doppler, which is also after this pulse wave Doppler, the next important type is actually the color Doppler. In the color Doppler, so there is a color mapping is present for the color Doppler. So meaning that there are two types of colors, red and blue. Okay? Red color is towards the probe, whereas blue color means away from the probe, away from the probe. So this color mapping is mainly, it indicates the direction of the flow and it will also indicate the velocity of the flow. But it does not quantify the exact velocity of the flow. Color flow Doppler imaging is not as precise as conventional Doppler imaging also. So color Doppler is also affected by pulse frame rate. It also has the same, same transducer will receive the pulses, and it will also, like, the same transducer will transmit the images and also received by the image. So it is also acts in pulses only. The ultrasound waves are also produced in pulses in pulse wave Doppler also. Then the next type of Doppler that is also important is power Doppler. This power Doppler will just indicate the intensity or amplitude of Doppler signal. It will not indicate the velocity, or it will not indicate the direction of the uh, Doppler movement. Okay, all the movement is seen amplitude only in the same color, and that color will indicate the amplitude of the Doppler signal. So this will mainly emphasize the quantity of blood flow. Okay, the main advantage of this color Doppler is it is sensitive for weaker signals when compared to the color Doppler. When color Doppler cannot pick up the waves, then this power Doppler can pick up the waves. And this power Doppler is also less dependent on insonation angles. Whereas normally Doppler is more dependent on insonation angles, but this power Doppler is less dependent on insolation angles. Then the last type of Doppler which is important is a spectral Doppler. Okay, in spectral Doppler, it will show the range of Doppler frequencies and their change in unit time in the form of the waves. So here, this spectral Doppler will help us to measure the exact velocity of the blood flow, and we can also measure the wavelength of the waveform of the vessel can also be measured. So this waveform is displayed above the baseline, meaning that it is analogous to red. Above the baseline, meaning that it is towards the probe. Below the baseline, meaning that the blood flow is away from the probe. And this, with the help of spectral Doppler, we can also calculate Ri. Ri is equal to peak systolic velocity minus n diastolic velocity by peak systolic velocity, whereas Pi is equal to peak systolic velocity minus minimum diastolic velocity by mean velocity. Okay? Then, with the help of the spectral Doppler, we can divide the vessels or art vessels into two types: high resistance vessels or low resistance vessels. In high resistance vessels, there is sharp upstroke and there is narrow angle of velocities are present. In low resistance vessels, There is low pulsatility, but there is large range of velocities are present. So this lower velocities and large range is present for renal arteries and internal carotid arteries, whereas high pulsatility is present for femoral arteries and aorta. With the help of this spectral Doppler, we can calculate peak systolic velocity and diastolic velocity. Volume flow rate can also be calculated. So these are the important points about the Doppler image. Thank you.